All right, so in this video, we're going to be going over how to solve a systems of equations with quadratics. So we're going to be using what we call the substitution method. And what that means is we're going to take one of these equations and we're going to solve it for either x or y. And what we're looking for is the equation that looks way less complicated, which is the second one here. And the easiest thing to do would be to solve it for x. So if I take this 3y and I subtract it to the other side, I will get x equals negative 3y. And so that's the equation that I'm going to use to do my substitution. All right, so now what I have to do is I have to copy down this entire first equation, but every time I see an x, I'm going to be replacing it with negative 3y instead. All right, so we have, right from the get-go, 2 times x squared. I'm replacing that x with a negative 3y, plus 3y squared, plus 3 times x, and again, I'm replacing x with negative 3y, minus 12y, minus 42 equals 0. Okay, and now I'm going to have to go ahead and simplify this thing down. We're going to do parentheses first and then exponents. So we have an exponent of 2 here, so we're going to go ahead and simplify this whole expression here. So if I take negative 3 and I square it, that would get me a 9. And if I take y and I square it, I would get a y squared. So I'd have a 9y squared here. And then multiplying the 2 with the 9, it turns this into 18 y squareds. We still have our 3y squareds, nothing to simplify there. I can multiply this 3 in here to make this negative 9y. Still have my minus 12y and still have my minus 42. Okay, then combine all your like terms. So here's your y squareds. That's going to get me a 21y squared. Our y's will be combined to get a negative 21y. And our last number here is a negative 42. All right, so now we've got a quadratic equation that could be solved by factoring, it looks like. All right, so if I notice here, the GCF in this entire thing is at 21, so we're going to divide everything by 21. And that's going to get me a y squared minus a 1y minus 2. And that is something that can be factored. All right, so when I factor this, I'm going to get y minus 2 and y plus 1. Still have my 21 out front, but it will not change my solutions. So from here, I'm going to get y equals 2 as a solution. And from here, I'm going to get y equals negative 1 as a solution. However, these are not my answers because I'm solving a system, which means I have to find x and y. So I just found 2 y's. So what I have to do is I have to find their x's that are paired with them. So for this first one, for y is 2, all right, I have to find out what its x would be. So I can just use this equation that I created here. This x equals negative 3y. I can plug a 2 in for y, and I would get negative 3 times 2, which is negative 6. So I know that y of 2 is going to have a negative 6 for its x. So that gives me a solution. It gives me an ordered pair of negative 6, 2. And then the last one, my other answer was y is negative 1. And so I'm going to do the same thing. I will be plugging a negative 1 in for y in this equation up here. That's going to get me negative 3 times negative 1, which is positive 3. And so I get x is positive 3. And so here is my other solution. All right, so the goal here, again, is to use the substitution method. Take the easiest of the 2 equations, the one that doesn't have the powers of 2 in it, one that just has powers of 1. Solve it for one of the variables, so whichever one is easiest. And then once you get that equation, you're going to be substituting that back into the difficult one. And then it's just a lot of simplifying. And then you'll get a quadratic equation like you do in this step. This one was nice because I could factor it, and it was quick to find the solutions. But once you get the quadratic equation here, you can use any method that you want. So that would include completing the square, the quadratic formula, or factoring, or graphing method if you have a graphing calculator. I would suggest trying to factor it first, and if you can't factor, I would probably revert to the quadratic formula. All right, thank you for watching.